All right. Hello, everyone. My name is Sam. I'm from the Clayton Foundation. Today, I'm going to talk about technology for open Web3 governance. So, in Web3 project or in blockchains, we have many topics that we have to make our decisions. For example, token, how much token we have to inflate. I mean, and also how much grant we should use for ecosystem and the project in the network, and how much budget we have to put for marketing, and what kind of technology we have to develop, and after developing the technology, so whether we have to do hard fork or not. So these kind of decisions, something that we have to think about when it comes to the governance. And so with these topics, the important thing is who's going to make these decisions and how are we going to make these decisions. So in this aspect, we can define the Web3 governance or blockchain governance as a system or the process in which the participants in the blockchain ecosystem make decisions and on major issues to achieve common goals or to solve common problems. So when I was doing some research on how the governance frameworks are existing, I found one good thing from the IEEE. So the IEEE has a the governance working group, the P2145, and then they define this kind of governance framework that is called 4P plus I. So we have POP, and this is basically about the structure and the processes for providing direction and control for the governance. So we have four parts of peace. So first one, the people, and the people means who's going to make decisions, and the process is how are those decisions made, and the practice means how are decisions executed or enforced, and lastly, it's about policy, and the policy here means what decisions are made and then how are they codified or communicated. And of course, to encourage this and we need incentive model as well. So today, I'm going to focus on among this framework. I'm going to focus on two parts: the participants and process, from the perspective that's who's going to make decisions and how are we going to make decisions. First one. So in democracy, so we have, basically we have two models. But of course, we could have more models, but the popular ones were direct democracy or representative democracy. So we have people, and then they vote, and then, in direct democracy, those people make decisions about rules and laws. But on the other hand, the representative democracy, we vote, and then we chose representatives, and then those representatives make rules and laws. In blockchain, we have similar system in the delegated proof of staking system. So compared to the proof of stake system, and the delegate POS system usually have representatives, and those representatives make decisions depending on the amount of stake they have or the amount of stake they got delegation from the stakeholders. So today I'll take an example of Clayton as in my talk, and then talk about the necessary topics using the example of Clayton. So for those who are not familiar with Clayton, I'll briefly introduce Clayton. And Clayton is an EVM compatible chain. It's a public blockchain, and it's been learning since June 2019. But we use Istanbul BFT for consensus, and those who are participating in this consensus are actually the entities who make decisions on governance agendas. So they are validators in network, and as well as the governance decision makers. And the list of them are on the right side. And Clayton provides unique account and transaction model that is very similar to account abstraction in Ethereum, and we developed this a long time ago. And recently we are focusing on making real changes through the real-world asset tokenization and digital ownership and Asia expansion. And we have this high performance and low gas fee model. And I'm gonna talk more about our governance structure because this talk is about governance. So we have the entity called Clayton Governance Council, and that consists of members on the light side. And we are currently have about 36 companies or projects from Web2 or Web3. And again, they are in charge of the operating validator nodes as well as making decisions on governance. And then the important thing about in governance and regarding this governance council is how we can choose the members in governance council and how they are how they can be changed during the time. So in the past, we have I'm from Clayton Foundation, and Clayton Foundation made decisions on who will be the governance council member. So we invited new members to this GC structure, and of course we discussed together whether they want to be a part of this governance council and so on. And since then, we changed the policy so anyone can apply for the GC membership, and then the existing member, existing governance council members vote on those applications. And the discussions is done on Clayton Governance Forum, and then the voting itself is on chain right now. And we'll move further from this. And so in the future, so the community will vote on these applications, and that means community, Clayton community, will decide who will be the governance entities in the future. And again, so I mentioned that the governance council members are the same as the validators at the moment. So to define who will be the entities in governance means that who will be the validators in the Clayton network. So here I'll talk a bit more about how we choose validators and how this selection process will be changed in the future. So yeah. I mentioned that at the moment, this governance council membership is approved by the existing governance council, but again, we'll move toward that this process should be the permissionless and open to the public. So then what is the permissionless validators? So to implement, permissionless means that anyone who has the proper qualification or proper, who has met the proper conditions to become a validator can be a validator in the network. So that's the meaning of the permissionless in Clayton. So to implement this permissionless network or to permissionless validator structure, so we can define these two concepts, the validator candidates, and among these validated candidates, we can choose the real validators. And of course, we need some qualification or criteria that we can use for choosing validators. So, to implement this idea or this structure, we have to solve some technical challenges. So technical challenges come from how to choose these validator candidate, or how we choose a validator from these candidates. And again, moving from permission network to permissionless means we have to deal with the security and stability issues as well. So we need a systematic way of entering and leaving validators while preserving the network security. Of course, we need to prevent the DOS attack and IP spoofing and hacking and so on. And we also need a mechanism that's that replaces malfunctioning or underperforming validators while keeping the network stability. So yeah, I mentioned that we are using Istanbul BFT for our consensus, but for those who are not familiar with BFT consensus algorithm, this is just simple, not a simple, but diagram typically represent the BFT algorithm. So as you can see here, this diagram basically shows the complexity of the message. So the message complexity in this algorithm is the order of n square. So that means if we have more nodes in the network, I mean in the validated network, that means the message uh, complexity becomes very high because it's proportional to n square. So I mean to make the network permissionless and to allow more validators to participate in the network, then we need a way to limit the number of messages and while we are increasing the number of nodes. So to implement and to solve this problem, and we need the new consensus algorithm, or we need to optimize the consensus implementation, and or we have to come up with a way that can limit the number of actual validators participating in the consensus. So this is the actually already implemented in the Clayton, but conceptually we need some subset from the validator set, so they can actually participate in the network while reducing the number of messages. And the second challenge is about the block time. So Clayton's block time is 1 second with immediate finality. That means we need to really care about the network latency. So when you break down the time for the block generation, so a lot of time is used for the network transmission. But so again, I mean this means that the physical network latency affects a lot to the performance of the network and the block time. And so we have to really think, carefully design that the distribution of the validators in the world, physically. So this shows that the network latency from Seoul and Singapore, and then at the moment, to keep the 1 second block time, we keep the network latency within 150 millisecond. But yeah, but to overcome this limitation, we need a way. We need a way that we can distribute the network over the world while maintaining the 1 second block time. But this needs to solve that this geographical challenge in terms of the network latency. So with this permissionless validator network, again, we'll choose some of them from this. We'll choose a governance council who are actually the governance body in the network, and so conceptually, the governance council come from, some of them come from the validators, and some of them will be just purely the governing body in the network. So this is about how we choose the participants in the governance in the network. And this is the example of Clayton. And then next, I'll talk about how the decisions can be made through what kind of process. So, we have traditional governance model that is basically off-chain model. So so sometimes this is hierarchical and role-based and trust-based and political, and the participants have static power. But on blockchain or Web3, we have on-chain governance as well. So on-chain governance means that there's more horizontal, and there are no fixed rules, and trustless and apolitical, and the voting power could be fluid. So we have, in Ethereum ecosystem or in the Web3 ecosystem, we have the tools for on-chain voting or on-chain governance, and also off-chain governance thing, and so on. So for off-chain, the snapshot is heavily used, and for on-chain voting or on-chain DAO management, the TUL is the one example tool that can support this on-chain governance. And in Clayton, we have the governance portal called Clayton Square. So in Clayton Square, we provide information about the governance council that I mentioned. So basically, it describes who are the governance council members and how much they are staking on the network, and who joined and who left this governance council, and so on. And apart from this information part, we have the on-chain voting system, and this on-chain voting system, the GC members can vote on a governance agenda, and they can also see the voting process. And of course, this is the public system, so anyone can see the history and the status of the voting agenda as well. And in the future, so through this, because this is everything about Clayton governance and the activity and the community activity, so we'll disclose more information about treasury and the community activities and ecosystem and so on. And yeah, again, and we allow, we enable the community to be participating more in the governance and this decision-making process. So in terms of process on governance, so there could be many different ways of how to vote on agenda. So it could be identity-based voting, or it could be the hash power-based voting, or stake-based voting, and so on. So we can think of or some combination of these different mechanisms. So then, we can think of different mechanisms of voting, but also we need to think about how voting power can be defined for each participant and depending on what. So we could think of at least 3 models. So each participant can have equally the same voting power, and the voting power can be proportional to the stake amount of stake, or the amount of the delegation. But the problem of the second approach is, someone who has a lot of stake can monopoly or can make a decision by themselves. Yeah, but to minimize that monopoly issue, so we can have something that similar to the second approach, but we can also set up the maximum the voting power. So basically, that means the voting power can be proportional to the amount of stake or amount of delegation, but it has the maximum capacity. So on Clayton, we follow the third model. So basically, our voting power on Clayton is proportional to the amount of stake, but the one vote is assigned per 5 million clay. But we have the maximum voting power per each governance council member, and that is defined as the total number of GC member, the -1. For example, if we have 10 members, then the maximum voting power that each member can have is 9, because we do -1. So this mechanism can prevent that a single member cannot make a decision alone. And okay, we talk about the voting mechanism and voting power, and then next is how we are going to make the voting. And this is about the voting process in Clayton as an example. So we do have two different parts. The one is the open chain discussion part and an on-chain voting part. And for the off-chain discussion, we are using the Clayton Governance Forum, and that where the proposals is posted, and the discussions within community or within the GC members is held. And after discussion on the forum, we move to the on-chain voting, and that is that on-chain voting is happening on the Clayton Square that I introduced before. So this is the example. So we have this off-chain discussion part, and then after that we move to the on-chain voting phase. So once announced, when we move to the on-chain part, and then we announce the agenda to the portal, and we start the voting, and the voting will last about 7 days to 14 days, depending on the configuration. So so every GC member to cast a vote on the voting agenda, and once that agenda is passed through the voting, and then we implement the result by ourselves or through the governance council. And in this voting process, the important thing is because the voter list, that is the governance council members, and also the voting power can be changed anytime, and because these are the data that is changed in real time. So we need to, at some point, we need to finalize who will be the voters and how much voting power they can have. So we have these two pages. So we first finalize the voter list. Yeah, so that means who will be the participants on voting, and then after some period, we finalize the voting power depending on the amount of stake. Yeah, so after finalizing these two, we actually start the voting. Yeah, and the voting is, and everything in this process, every process, described here is implemented on smart contract. So to end, so the for Web3, because even though the blockchain is transparent and we are trying to be transparent and making a good decision, but still the many things and the many decisions are made by humans. And so, but for this Web3 and the blockchain ecosystem or industry to grow, we need the transparent and easy to participant governance system. So each participant in the ecosystem can express their opinion easily and can choose the proper decision. So to conclude, we need better open governance system for this industry and for this ecosystem. And so the participation and then decision making can be done in a transparent and efficient way. Thank you for your attention. If you scan this QR code, you can find more information about Clayton and Clayton Square and other topics that we are working on. And thank you again. I'll take some questions. I think we have some time. Yeah. Thank you.
If you have some question, raise your hand and I will bring you the microphone. So I know it was a very long one, but don't feel shy. I think there is no question. So
okay. Yeah. Thank you again. Have a great day. Yeah. Thank you.